Ok, scusa. Ok, passo un attimo la parola di Enrico, il CEO di Fiscozen, e poi partiamo e switchiamo all'inglese. We will switch to English after.
You don't need to speak English already. I'm fine with it.
Okay, as you want.
Okay, so welcome to Fiscozen. I'm Enrico. I'm the founder of the company. Brief history about us. We build technology to help freelancers to take care of all the taxes, invoicing, tax filing that you need to do in order to work in Italy as a freelancer. Okay? And we started in 2017 using Python as a technology stack. So that's one of the main reasons why we really like to have you here guys tonight. That's super nice for us. So thank you for coming. I'm super curious to hear you. One of the reasons is that Giulio will be speaking, which is one of our software engineers in Fiscozen. And I find it super nice when, software developers kind of ask themselves, how good the software need to be and how much do I need to care about performance or these kind of topics, which as an entrepreneur are quite relevant, as you might understand. So that's super nice. Again, thank you for coming. This is the third time, and anytime you want to come, you're welcome. Okay?
Thank you, Enrico.
Enjoy. Ciao.
Okay, a brief presentation of the group. So I think that most of you already seen these slides, so I will go fast, but it's not. Okay, what we do, so basically we do 2 monthly meetups. We have this one, Python Milano, which is the historical one, and then we opened another chapter, the PyData Milano, for stuff more data-oriented, let's say. We do also a podcast, Intervista Pythonista. We met, have a beer. After this meetup, we will go to dinner. You think about it. If you think you will join, everybody is welcome. And we also help a little bit organizing a conference. This is Py4AI. And, but also we are present to Python Italia, for example, as speaker or volunteers. Okay, this meetup is sponsored by the Python Software Foundation Network. Okay, this is all the meetups in Italy, which are official. Go. And okay, we want to thank you. In 2026, our hosts are Fiscozen today and the Team System, but we are kind of nomads. We go in many venues, and so this is all the venues of 2025 and 2024. And okay, also we are sponsored by Python Italia that gave us the microphone for the podcast and stickers. I have some stickers, maybe I will distribute a little bit more. And we want to thank you also, Alessandro Re and Division Lab, for buying us all the gears for YouTube. So now we are all YouTubers. If you want to join the organization, you have to learn. Since we are organizing a kind of streamlined group for doing meetups, you have to basically learn to go on YouTube. Otherwise, you will not join. I'm joking. Let's go. And okay, next meetup is February 28th at Iliad, and I think that's it. No, there is, no, the most important thing. We are media partner of PyCon Italia that will be in Bologna 27 and 30 May. So I think we have now the price of the ticket raised a little bit, but stay tuned on LinkedIn because I think that they will give us some discount code to Python Milano, so we can spread a little bit of discounts. And that's it. So next, it's Giulio that will challenge a very known programming pattern. So I give a big round of applause for Giulio.
Thank you.
And I don't know if this is working, but in any case, just tell me
I'm not
that.
sure. Oh, it was. but it's still not
Oh,
working. Yes.
No, it's working.
Yeah, it was turned
Nice.
off. So I have to be honest, I didn't prepare this speech in English, so it's a surprise for me. It's my first speech in English, public speech, so I hope everything is fine. And I also hope you came here, I don't know, a little bit hungry, because I choose this, I don't know how to say it, provocative title, just to trigger you a discussion later. So, okay, before talking, sorry, you were just wondering, I think, who the fuck am I to talk? I am Giulio Davide. I am a developer for 5 years, and right now I work in the, I think I can be sure about that, the best company in Italy. I'm a software engineer at Fiscozen. I'm an open source I'm an open source contributor. You will never know if that's true or not, but I saw that I don't know, a lot of people write it and seem to be cooler. So it seems cool enough to write it on the slide. So I'm talking a little bit about me. My personal object in personal life is to be a serial watch collector. When if my I don't know how to say. Sorry, I'm a little bit emotional because I love a lot watch, but I don't have enough money to buy them. So I hope in the future to have more money to buy them. Sorry. I love music. I love rock. Rock is my favorite genre, musical genre. But in the meantime, I discovered a lot of cooler music genre. Why I choose this topic? I choose this topic because at the beginning of my career, about 3 years ago, I came into this video from Casey Muratori. Slides will be available later, so you can see also this video later. Casey Muratori is an Epic Games developer. Who in this video in YouTube, he benchmarked clean code performance versus more unreadable code. And we will see later the result. Sorry. After that, the main reason why I choose this topic is because I hate unquestionable truths. I always ask why something is done this way. And at the beginning of my career, in the review of my PR, in the review of my first PRs, I often received a feedback like, write it this way because it's cleaner, etc. So I started asking myself, sorry, is clean code always the best choice? After seeing this video of Casey Muratori, I also started questioning myself, but could be clean code the reason of a lack of performance? So I'm mentioning clean code, please clean code that, but let's go back to basics. What is clean code? Clean code is a set of beautiful guidelines. It's a set of guidelines with beautiful names. For example, the first guideline, don't repeat yourself, just says that you have to keep your logic in one place to avoid errors and facilitate maintenance. Let's go with an example. Imagine we have two shapes. Sorry. Imagine we have two shapes. We are computing the area of these shapes. Don't repeat yourself says to us, extract the common logic, so the multiplication of two sides, and call in a function, and call that function in different point of the software. The second guideline, I think my favorite guideline, is Yanni. You aren't gonna need it. Why it's my favorite? Because for these slides, I didn't need to write a code example because it says we don't have to write code that we don't need, sorry. The last guideline I explored for this test, but not the last for importance, is solid. Solid is a set of other guidelines which says, for example, for the first, that every software entities has to have one responsibility, single responsibility. This guideline is similar to the keep it simple, stupid guideline. Okay. In the example I wrote on the slide, we can see how the class shape has only geometric responsibilities. Instead, the shape matrix class has different responsibilities to compute particular metrics on other shapes. The open-close principles that says that software entities should be open to extension and not to modification. In this code example, in this code snippet, we can say how it was easy for me to extend the functionality of the shape class by implementing the functionality of the shape rectangle without modifying the original shape, sorry. The list scope substitution principle instead says that object of a superclass should be substitutable by objects of the subclasses. What does that mean in a code base? It means that, for example, in the case of the shape metric class, where we have the complex value function, we can specify the parameter shape as a generic shape. And then imagine we have also circle class and square class. We can use the specific subclasses in the complex value function. The interface aggregation principle instead says the software should be divided into different independent parts. In this case, in this code example, the interface aggregation principle is represented by the two different classes which are independent between the other. If, for example, I want to edit the complex value function to have other function or other scopes, I can do it without modifying the shape class. And at the end, the last principle, the dependency inversion principle, which is similar to the TDA, tell don't task principle, says that we should rely on abstraction of classes and not on concrete implementation. It means that in this case, always referring to the complex value function, we are relying on the shape class, the superclass, to understand the functionality inside the shape object. What are the advantages of clean code? For sure, clean code is more readable than is a readable code. Readable code is a code base. Is code where it's easy to collaborate among in big team. In big teams, there are a lot of. It could be possible to not know all the part of the software itself. So clean code is easier to understand when you never saw that part of a software. Readable code is also code which is easy to test because segmented software, as we saw in interface segmentation principle, is easier to test, unit test it, and also to debug. So this is the summary I wrote about clean code. These are the main, in my opinion, the main guidelines of the clean code. I can spoiler to you that for this test, the dry and Yanni guidelines are not important because it's difficult to not agree with these guidelines because they say that you don't have to repeat code and you don't have to write code which you don't need. For this test, we are only working on the solid principle. The solid principle basically say three things. for me, in my opinion. Sorry. The first thing they say, it's that we have to prefer polymorphism instead of if, else, or switch cases. They say also that we have to avoid to expose internal details of an implementation. And also they say that function or software entities should do one thing. What are we going to test right now? We are going to do performance tests on classical clean code example. In particular, we are testing the area execution time, the function we saw in the previous slides, and also the complex value execution time. This is the code I wrote for this test. I implemented a shape class with area and size method. I also implemented the rectangle, square, triangle, and circle shapes. And I also implemented a class with a custom matrix that divide the area and the size of the value of the shape itself. The setup for this test, this test will provide 50K samples per function. We will execute every function 1,000 times. And this is the how a single fixture will be formed. We will have two sides, side A and side B, and also we will have the shape we are going to instantiate. After the generation of the fixture, sorry, if the shape chosen is a square or a circle, we will adapt the two sides A and B to be equal, just to have realistic result. The performance test will be a unit test in which we will just assert that the execution time of the unreadable code is smaller than the clean execution time. Sorry. Okay. For the first test, we are going to compare the execution of the area function of the fixture, of the shape chosen by the factory, with a code wrote in a more unreadable way. I hope you are, I don't know, suffering from seeing this piece of code I wrote with if-else case nested among them. I wrote it in the, I don't know, ugliest way I could. And after wrote these two functions, I don't know. Sorry, spoiler. No.
There is a lot of space.
I did my best to be the more readable, I mean, with the text, but not with the code. So back to the topic. I ran the test, and I saw that unreadable code had a performance improvement in the about time, just time execution of 55% about. So I said that there are two other guidelines that could say that I'm lying, that I'm not right, sorry. And I decided to test the second guideline that says that we have to avoid to expose internal details by keeping the clean code implementation and by just extract the internal details of the implementation of the area function. In order to do that, I pick the common factor, which was the multiplication of the side A with the side B with mi viene il termine in inglese, scusate, coefficiente, coefficient, sorry. So I pick the common factor and extract the coefficient, which in the case of the rectangle and the square were just 1, and the other case were 0.5 and pi greca. And I run also for these two functions the test. And I saw that, in this case, we had an improvement of about 65%. So, at the end, I said that for the last guideline, the result should be already known. But I decided to test it anyway. For this case, I decided to test the complex value function that we saw in the previous slides. For the clean code, we can say that the implementation is similar to the area part. So we just instantiate the shape chosen by the fixture, and then call the complex value function for that shape. Instead, for the unreadable part of code, I extract the coefficient of the common part again, and in that coefficient, I did all the operation the simple operation I was trying to test. I ran the test, and I saw that I had a performance improvement of about 80%. So the question was, to be clean or not to be clean? Why?
I would say most of the time, if you're not working by yourself, and like that's a normal case. You're working always with someone else, and clean code is much more maintainable, it's more readable, everything you said. On top of that, like performance are most of the time something that can be, addressed with horizontal scaling. Let's say I had an event. I was working for a company where the performance was the only concern. I wrote the worst code I've ever wrote in my life. I also needed to read, I'm talking about JavaScript, but I needed to read the V8 engine to understand how to write the code to actually be more performant. The code was crap, literally was crap, but it was performing so well that everything was fine, and we actually stick with that code. Actually, the whole code base was 5 files. Okay, so I could actually say this is 5 files. I brought documentation for every single file. Everything was fine, but the code was crap. Okay, but again, this basically is a trade-off between the size of the code base you are working on and what you are trying to achieve. Also, is scalable, achievable in a different way, and what's the cost of achieving the performance through horizontal scaling instead of writing crap. Because at the end of the day, like the massive cost a company has to sustain is the cost of the developers, right? And if you are spending twice the time because you need to read something that is completely unreadable, then your cost is higher than the server they are paying to actually horizontal scale with good code. So it's a kind of a trade-off, but I would prefer to have nice code, documented and well written, also for future due diligence or whatever, rather than having crappy code that is not going to be maintainable. And at some point, someone will come in and will say, you know what, guys, this is completely unreadable. We need to rewrite it all because no one can maintain. And if you're leaving and you wrote crap, basically all the people that will come later will be very.
But that's a good excuse to ask for a higher paying.
Yes, but again, you are not delivering something that the company could maintain, so they might just fire you. But you can ask for it, okay, right? For sure.
Okay, so another one want to talk? Yes?
I wanted to ask if, thank you. Inside of your experiment, did you look into like a breakdown of all that time?
Sorry?
like, did you look into like, okay, like you said, like it took like 7 seconds to run, right?
Okay.
Did you look into like how was that time being spent? Like an estimate, for example, of like how much time was it instantiating classes?
I didn't go didn't dive into this just because this talk was also just to trigger a discussion. Because in the video I linked at the beginning of the slide, there is a much deeper analysis of this
Okay.
phenomenon. Is also wrote in C++. So Casey Muratori, which is a video game developer, analyzed the CPU, time execution, and something like that. A lot of things. I don't want to spoiler because it's a very interesting video. So I just decided to, I don't know, tried it in Python and try also to trigger a discussion among us.
Yeah. Okay. So can I follow up?
Yeah.
Because like I think that it was like the point has been kind of made already that it's not a yes and or no answer. It's a matter of like trade-offs, right? In the sense that
Okay.
like you can also make the point that whatever you save in efficiency, then like there is an increased likelihood of things going horribly wrong, and you have to like take that cost and like spread it in function of the frequency by which things go horribly wrong.
Okay.
Like if the code is cleaner, I would assume that things go wrong less often.
So you mean that if the code is cleaner,
things go wrong less often, and then you don't have to incur the cost of things going horribly wrong.
Okay, I could agree with this.
Yes, and
if
also,
code is cleaner, maybe it's easier to maintain. I agree.
And inside of the idea that it's a bit more of a trade-off question, I think we're like doing the experiment in terms of like, how much compute or how much time is any specific step taking. It could be informative in terms of thinking of like, what is the cost of applying each of these principles.
Okay, so you mean that I could do a better analysis by just try every single
Like,
guideline?
I don't know, like for example, like I think that if instead of initializing a new class every time you want to calculate the area, you instead initialize get only the one object and like shift the attributes around, the time would probably be different, and this would probably be a bit further away from being clean code, but not quite as far as like just writing a function.
Yes.
So in that sense, I think that like it can help narrow down where like what's the sweet spot on the.
I can agree with you that the most of the time in my code snippets is spent in the part of the function calling. I think that's the part where you spend most of the time. If I have to be honest, in the various experiments I did before coming to this conclusion, I saw in terms of time that most of the time is spent calling the function.
Okay.
I'm not sure about that, but I think so, because this this snippet of code, it does not seem easy, but I think I worked on that 2 months. So I think that you are right that most of the time is spent calling the function or instantiating the object. But I think also that this is due to the fact that I am trying in the first snippet of code to follow clean code guidelines. In the second part, I just don't call a function because I don't give a fuck about following clean code guidelines. But I also am sure that
in that
Python,
sense, I'm saying like some clean code guidelines are gonna be more expensive than others.
For sure.
In that sense.
Exactly. Okay.
Sorry.
So I will be a voice in a sense in your favor, in the sense that I understand that The answer to most questions in life is it depends. I understand how game developer who has to work with shaders and has to work with high efficiency, has to write high efficiency software, has to face this problem. I've kind of faced it writing some MicroPython for microcontrollers, where I started writing code that was sort of clean. And then basically it was so slow, I had to go back to basic functions and delete everything and write the worst code of my life, just so it had not have issues of buffering things on the screen, things like that. So clean code is not about performance, though. It's about readability, maintainability. If you are not in a condition when you can scale, if you are really constrained situation, I understand it makes sense to get rid of it, okay? But you always have, I think, to find the balance between something that's maintainable and something that's efficient. Nowadays, we are not used to having issues with performance, because we live in a world where you just increase you scale everything up, you scale the resources, you scale the instances, and you forget about it. But it used to be a real issue when, especially my experience for old code is mostly video games. So especially when you had to write video games, when Carmack had to write Doom, his main issue was performance. So I guess most of his software was not clean code at the time. So so that depends.
The funny part about that is that presenting this talk to some friends, etc., they told me, I don't know if that's true, but they told me that clean code born because of video games, because of the fact that in a lot of video game video game code, there was unreadable code. So I think that they told me that it born in the video game area, then expand to all the software developing. I don't know. Yeah, just the last one, just because they also.
Did you try with other languages? And I'm curious about the results in C++, because let's say Python is not native OOP. So I'm curious about the others.
So in the video at the beginning of the slide,
that was the C++. Yeah.
No, I didn't try other languages also, because if I tried with other languages, I couldn't do the talk in Python Milano.
Yeah, of course. But in the book, in the video they tried something else, or just
no,
C++?
Just C++.
Okay.
Yes.
Okay.
So guys, I have to go on. But non funziona? The answer is, as someone of you said, that it depends. Vai avanti. No, lascio così. Okay. I said at the beginning of my talk that I am a developer for 5 years. So I am relatively new to this world. I don't know if I can say it. So my opinion about the topic is evolving. Right now, I think that it's not a fight, but a trade-off. Because I think that we as a software engineer, we use technologies, and we are not used by ideologies. So this cool motto is generated by me and not by ChatGPT, as the slide before. So whenever you will use it in the near future or in the future, you have to mention me. Thanks. Avanti. What's the software engineer aim? I think that the software engineer aim is to find the most suitable solution to the problem he's trying to solve, and not to support a solution by default. At the Politecnico di Bari, in my university, a lot of professors teach me that the aim of an engineer is always to find the less pessimistic solution. What is the less pessimistic solution? the solution that in the worst input returns the best output it could. So how can we fit this idea in the software developing world? I think, as someone of you said before, that it depends on the domain we are working on. For example, if we are working for big tech where performance are not important, I think that it has a lot of sense to try to write clean code, just because we have a big team with a lot of people that have to work together and understand what other people are writing on their code. Instead, if you are working, for example, in a domain where performance are more important, I don't know, video games, etc. I don't know, just to do some examples. I think that it's more important to be focused on performance. There could be in the future some problems in some part of the code, but so whenever part of the code can be problematic and not readable, it has for sure sense to write code that is cleaner, and it is also easier to maintain in the future. I don't know if there are any questions about the test. Bye.
Any questions? Any more questions?
Mm-hmm.
Ancora.
No, I wanted to throw in one more. The one. I wanted to throw in one more thing is that, and again, it's a more serious problem depending on the domain, is that I feel that the cost of clean code is more easily quantifiable. The costs of unclean code are a bit more of a gamble. So there is that.
As I said, I could agree with that because I think always that it's trade-off. So I can agree with that. It's arguably, it's difficult to not agree with what you said. Guys, keep hydrated.
Any other question for Giulio or Giulio Davide? I don't know what it is. We have.
As you prefer.
Yeah, it's other question. No, it was nice that one of my first job, I think my first job, was, you know what is a TL1 agent? TL1 is a protocol for telecommunication.
Okay.
And there was a parser. Okay, and the person, I was a junior, and the person says, we have to add a command to this parser. And I said, okay, how? You see this for loop with the 5 for nested? You take this one from this line and from this line
Okay.
after, and then change something, and you have a new command.
Okay.
So it was C, it was an embedded system. So that was the first job that I did. So
this is don't repeat yourself at its best.
Yeah, exactly. So yeah, I prefer a little bit of clinker in this case. But thank you for your speech, and
thank
big
you,
applause for Giulio.
At the end of the slides, I leave some sources I used for the presentation, and thanks for the attention. And if you want to follow me on the social, LinkedIn and GitHub, I will leave the slides there. Thank you again, and sorry, I was a little bit emotional because it's my first speech in English.
And watch Casey Muratori videos because they are quite good. And okay, did you think a little bit about the dinner? Anybody with